Distinguished ladies and gentlemen, I want us to look at the equation of tangent to a curve. And having a look at the equation of a tangent to a curve, I want us to consider this question so that we get to understand how you can find the equation of a tangent to a curve. Now, the question is find the equation of the tangent at 2, 12 for the curve y equals to 2x squared minus 3x minus 2. Now, the first step that we shall take is we shall find that is the gradient function of the curve. We shall find the gradient function of the curve. That is the gradient function is just dy over dx. dy over dx equals to, that is we differentiate, that is a function of y with respect to x. Now, if we differentiate this is a polynomial. Now, we shall have, that is, we differentiate each term in turn. We differentiate each term in turn. That is, we differentiate 2x squared, then we proceed to differentiate negative 3x, then we proceed to differentiate negative 2. Now, let us differentiate this. If we differentiate this 2x squared, we shall bring this power, that is, we shall bring this power, that is, the power is 2. We shall bring it here so that it will be 2, then times the whole of this, that is 2x raised to 2. Then we less that power by 1. Then if we differentiate this, that is negative 3x, it will be minus the power of x here is 1. So we bring this power here, then we less the power by 1. And if we bring that 1, it will be 1 times 3x raised to 1 minus 1. Now, if we differentiate negative 2, because negative 2 is a constant, it will be 0. Now, we shall have, that is, we shall have, this one will be, that is 2 times 2x raised to 2 minus 1 is 1. Therefore, if I write 2x raised to 1 is just the same as 2x. Now, then minus 1 times 3x raised to 1 minus 1 is 0. Now, in this case, we shall have, that is 2 times 2x raised to 1. 2x raised to 1 is just 2x. Times 2 is 4x. Then 1 times 3x raised to 0. X raised to 0 is 1. Then 3 times 1 is 1. 3 times, not 3 times 1 is 1, but 3 times 1 is 3. And 3 times 1, it will just be 3. Therefore, it will be minus 3. That is, if you say x raised to 0 is always 1. Any number raised to 0 is 1. Or any unknown raised to 0 is 1. Therefore, x raised to 0 is 1. Times 3 is 3. Times 1 is 3. And therefore, the gradient function is 4x minus 3. Now, after obtaining the gradient function, we shall now find the gradient at, that is at this point, because this is a point which has the coordinates as, that is 2, 12. That is a point that has the coordinates as 2, 12. Now, we shall find the gradient of the curve at the point 2, 12. Now, we can say that at 2, 12, at the point 2, 12, that is at the point 2, 12, that is dy over dx is, dy over dx will now be, we have the value of x as 2 at this point because the coordinate is always in the form of x, y. Therefore, x is 2 and y is 12. And in our case, our dy over dx is 4x minus 3. Now, since we have 4x minus 3, we are going to substitute, that is x with 2, so that we can obtain our dy over dx. And therefore, it will be, that is 4 times x, which is 2, then minus 3. And therefore, in this case, we shall have 8 minus 3, which is just 5. Now, our 5 is the gradient of the curve. And I want us to take note of this, that the gradient of the curve is the same as the gradient of the tangent to a curve. Now, the gradient of, that is the curve, the gradient of the curve is 5, which is just m1. Now, if the gradient of the curve is m1 and it is 5, I have said that the gradient of the curve is the same as the gradient of the tangent to the curve at a certain point or at a given point. And this is the point that we have been given. If the gradient of the curve is 5, that means the gradient of the tangent, of the equation of the tangent, is always the same, and it is m2. Let's say the gradient of the tangent is m2. We can say m1 is the same as m2, which is 5. Therefore, the gradient of the tangent is 5. Now, having the gradient of the tangent as 5 and the coordinates 2, 12, we shall find the equation of the tangent in this form. That is 2, 12. Then we take the general points, that is x, y. Then we take our gradient of the tangent, which is just 5. Then we proceed to find the equation. That is the change in y, that is y minus 12 over x minus 2 equals to 5. Let's say 5 is over 1. Now, if you cross multiply, you will have, that is 1. This one, we multiply with what we have in the numerator, that is y minus 12 equals to, if you cross multiply, it will be 5 into x minus 2. And in this case, we have our, that is our y minus 12 equals to 5 times x is 5x. Then 5 times negative 2 is negative 10. And in this case, we shall have, that is y, we shall have y minus 12 equals to 5x minus 10. And if we collect the like terms, it will be y equals to 5x. So this is negative. When it crosses this equal sign, it becomes positive. Therefore, it will be minus 10, that is plus 12. And in this case, we have our y equals to 5x minus, not minus, but it will be negative 10 plus 12 is positive 2. And therefore, this is plus 2. And therefore, this is the equation of the tangent. This is the equation of the tangent.